Alrighty, this is the first module of what I would call bonus material in the class. It is on image processing, which I think is both interesting and fun. Just a few background thoughts about images in general and how they work. There are a lot of different images formats that you'll find online. There's PNG, there's JPEG, there's GIF or GIF, depending on which side of that hot debate you're on, um, and several others. But they all sort of work the same. Most of what those image formats have in common is that they're compressed image formats, which means they do something to the image to reduce the file size to make it easier and faster to load the image through a network such as the internet. Um, in fact, the letters in GIF, GIF, actually stand for graphics interchange format. So it's actually a format that was designed to be very, very compressed. The difference between the formats is that they each use different algorithms or mathematical formulas to do the compression, and some are better at certain things than others. And if you study these a little bit, you'll understand why. But essentially, if you want to use GIF, you're probably looking for an animated file or a file with just a few colors, uh, because the way GIF works is by reducing the number of colors in the image and indexing them, and then using that index to specify the color of each pixel of the image. JPEG stands for Joint Photographic Experts Group, and as the name implies, that image format is good for photographs. So in other words, lots of variety, lots of different colors, and lots of different shades within a given image. So what that one does is uses a process called interpolation to basically remove the actual data between pixels and guess at what that color might be. And the quality of a JPEG can be adjusted from 100%, which is the highest quality, down to 0%, which is the worst quality. And what that adjustment factors is the amount of interpolation that takes place versus the actual image data that's there. By far, the most powerful, I think, image format in today's world is PNG, Portable Network Graphics Format, because it uses a mode of compression that is technically called lossless, which means it doesn't lose image data. And it does do a good job of compression, although the PNG files tend to be a little bit larger than a GIF or a JPEG of the same size. The quality is much, much higher. So if you're interested in high quality images, PNG is probably your go-to. Photographs, probably stick to JPEG. Line art, logos, drawings, text on white background or any color background, GIF is probably the way to go. So that's just some rules of thumb. The other thing about image processing that you need to be acutely aware of is once you edit, every time you touch a file and do anything to it, you are going to lose a little bit of quality. So you always want to be strategic about how you process images, because the more processing you do to an image, the worse the quality will get. And if quality matters to you, that's a big deal. For example, if you reduce the size of an image from, let's say, 400 pixels wide and 300 pixels high to half that size, so it becomes 200 pixels wide and 150 tall, those extra pixels are gone. So I can make that smaller image, I can scale that back up to its original size, but I can't take that image data that was lost, because what it does is if I'm taking an image and I'm cutting it in half size-wise, it basically takes every other pixel and throws it away. So if I take that small image, which is now worse quality, and I make it big again, those pixels that I threw away aren't coming back from the dead and being zombie pixels back in the image. They're still gone. All I'm doing is taking the image pixels that were there and doubling them. So the quality is still bad. It's just a bigger image now. So just something to keep in mind. We've all seen the CSI program, right? Where they have like the blurry cam footage of somebody's face that's like 5 blocks away running across the street, and it's like a profile of their face and it's all blurry, and they're like, let's enhance that. And then all of a sudden it's like they took that photograph from 3 feet away from that person. You can see the mole on their cheek because it's fake. That's only in the movies. Now, we can use AI to guess at what those pixels might be in an image, and it's getting better and better at that if we throw tons and tons of data at it. But realistically, you can't take a picture that's crap quality and magically enhance it to make it good again, because those pixels don't exist. The only way is to draw those pixels in by guessing using some kind of AI algorithm or just your imagination. Yes, it doesn't work with photos. If I have a photo and I take the size of the photo and I scrunch it way down to a tiny little photo and I throw away a whole bunch of pixels and then I try and make it big again, it's just going to be crap quality and big. You want me to show you? Let me get Photoshop out. Hang on. Okay, so here's a good, where'd that just go? This one will work. Okay, so here is a shameless picture of my daughter swimming at junior nationals, right? So there's quite a bit of detail in this shot, but as I zoom in, you can see the individual pixels. This is what makes up every image that you see is made up of pixels. It pretty much is. And there's lots of different paint here, right? So if I take this image now, this image is 800 pixels wide and 500 pixels high. This is a fraction of the original size of the image. The image originally was probably 3,500 pixels wide. And that's even smaller than what's being taken on your new iPhone. So this was taken by a DSLR camera that's probably 15 years old now. So at the time, it was a high resolution picture, but it still looks pretty good. You can still see a lot of detail there. Let's take that image and let's reduce the size dramatically. I'm going to make it now 100 pixels wide. So 100 pixels wide. The image now, see, I can see the pixels, but that data, that detail is lost because now it's only made of 100 pixels from one edge to the other. Okay, cool. So now if I take that image, let's say I want to make it back to 800 pixels wide. Watch what happens. Okay, so there you can see the pixels, but as I zoom out, it's all blurry because when I took it from 100 pixels wide to 800 pixels wide, all it did was like try and guess at what those pixels are. And so the detail is lost because it's just guessing at what those image pixels look like. So if I undo that twice, you can see that's the original again. Tons of detail, completely different. So that is a universal principle of image processing. The more you mess with something, the worse it's going to get. So you always want to be very strategic. You want to think about things like if you're going to scale an image or crop an image and filter it, you probably want to filter it first and then scale or crop it, not the other way around. Because you get a lot more bang for your buck out of filtering it first, because the filters rely on that detail in the image to do what they're going to do. So Pillow is a Python package It may or may not be installed, but you know how to install packages in PyCharm, right? So pillow is what we're looking for. And using pillow is quite easy. We are going to, we're not going to import the entire pillow library. We're just going to import image from pillow. So from pillow, import image should be the first line of your program. The file name is defined as a string. It could be a path, not just the file name. But if you want to keep it easy on yourself, just put your image file in the same folder as your Python script and put the file name in a string. Now, a way to make sure that you don't crash easily is using a with statement. We haven't seen this before, but if you say with image open file name as img, and then you put image.load, then you will not have an error if that file name can't be shown. I'm going to show you a different way to do this in just a minute. Yeah. Yes, it's local files only. You can't use Pillow, at least, to open a remote image using a URL or something like that. However, there are other ways to do that if you wanted to. Okay. Now, once you have an image file, remember how we used file as an object or a type of object in Python. Image is a very similar thing. A pillow image has different attributes. The format can be shown, the size of the image, the mode. When you do image.size, it returns a tuple, which is just like a list that has two elements, the x pixels and the y pixels, so the width and the height in pixels. Those numbers are very useful because it allows you to scale the image or come up with a model for cropping the image. And I'll show you how to do that in just a sec here. Okay, so a crop image works like this, the very top line. Notice that when I'm using some of these formats or some of these filters on an image, it's returning something. So I have to put that into a variable. So when I do image.crop, it returns the cropped image. It doesn't actually change the source image that I'm using. It returns something. So I have to put that. And then I'm going to have two image objects in my program. I'll have the original, img, and the cropped one stored in cropped. So if I do image.crop, notice this. It takes a 4-element tuple as an argument. So you can see the outer parentheses are for the function. The inner parentheses are because we're giving it one argument that's a tuple that has 4 elements in it. And those 4 elements are, the first number is the x coordinate of the upper left corner of the crop. So I'm basically giving it 2 points, x and y, and it's going to crop that out. So if I have an image that's a bigger square, I'm going to tell it those corners, and this becomes the cropped image that I get from that. It takes a little bit of thinking through and a little bit of imagination and probably some experimentation, but it's not too terribly difficult. So this is the top left corner, 300 and 150. So 300 across, 150 from the top. And the bottom right corner of the crop is at 700 across and 1000. So this image is going to be 400 pixels wide and 850 tall when it's done. Make sense? Kind of. Again, we want to play around with this stuff. So resized. This is a very similar one, but it takes just a tuple with 2 members, the width and the height of the image. In this case, I'm feeding it a brief statement that says, take the image width, use floor division, divide it by 4. You have to use floor division here because it wants an integer. If you give it a float, it's going to choke on you because you can't have part of a pixel. It can't be 350.5 pixels because there's no such thing as a 0.5 pixel. It has to be integers. So we're using floor division here. We're dividing the width by 4 and the height by 4, which gives us an image that is exactly 1/4 the size of the original. So that's a great way to do it. If you want to scale it, you could do these as a single variable, and then you can just use that to scale the image. You can scale an image, by the way, at different ratios than height and width, but you're going to get, things that look too fat or too skinny or whatever. So it's good to keep the same ratio for scaling an image. And then again, once we have an image object that's been modified or whatever, we can save it back to a file using the .save format or the .save function. And that's a great way. What I would suggest if when you do that is that you save it as with a different file name than the original, because if you save it with the same file name as the original, you're going to overwrite the original, and then if you screw up, you've lost all that data. Okay, flipped, manipulating images, we can flip them left and right or top to bottom. We can transpose and transverse the image. Transposing and transversing flip in different directions, and also rotate in a weird way. So you'll have to play around with those because it's a little bit difficult to explain. You can also rotate an image. One thing that I want to point out, in case you didn't notice, is that the image shape or the image dimensions, when you rotate an image in Pillow, the image dimensions stay the same. It's still a rectangle, the same size as the original. What gets rotated are the pixels inside it. So in this case, it chops off the corners because a rectangle that's rotated can't fit inside the same size rectangle. So if I rotate an image 45 degrees, it chops off the corners. If I want to keep the corners, and I'm okay with the dimensions of the image changing, then I put expand equals true as a second parameter. The default is expand equals false, so I can leave it off. But if I add it, then it expands the size of the image to make sure that the corners are kept intact and don't get cropped out. Okay, so filters, we have all kinds of different things. I would recommend looking those up in the reading if you want more information about them, but I also have some sample code that I'm going to show you here in just a minute. You can blur them. There's 3 or 4 different blurring algorithms that are shown here. And then you can sharpen an image, you can smooth an image, you can convert it to grayscale. Find edges is sort of a way of heightening the appearance of hard transitions in an image from one color to the next. Emboss will allow you to take an image and use the grayscale value of that image to make an embossed look. So all that to say is there's a ton of different things here. So let's take a break from the PowerPoint and jump into some code. Let's see how this works. Okay, I showed you earlier how to use the with statement to open a image file, but it can be as simple as assigning that to an image variable and using im.open. You notice I'm importing from PIL image as im. That allows me to call image with the shorter syntax of just im. So im.open, and I feed it the file name. And then I use image.show image.show will pop open a window in your computer's default image viewing app. So if it's a Mac, you're going to see it in preview. If it's Windows, I think it's like File Explorer or Paint or something like that. You'll see when you open it. But what it does is just opens the default image viewer. So this is the shortest possible image viewing program. If I run that, you can see here it opens up preview with my little nacho quote here. All that does is just show the image. Now, if I want to resize the image, okay, so I'm going image width times 2 and height times 2. Now I can show it at twice the size. And if I wanted to play around with that, I could say scale the width by 4 and the height by 2. And again, it stretches out. So you can do things that are ugly. You just don't have to do things that are ugly. It's easy to avoid if you're just using those scales. But now, if I go to a really big size, you're going to start to see the image artifacts here. And you can start to see the pixelation of the image, because again, you can't add more pixels to something. So I'm scaling it up, but I am losing that data. Now, if you look on Canvas, you will see this file here. And I'm using a file called buildings.jpg, but you can replace that with the file of your choice and play around with this. But what this does is it allows you to play around with all kinds of different filters and image editing, image editing functions that are part of Pillow. All you have to do is take these and uncomment them one at a time, or in multiples if you want, just to show you what the image looks like in its vanilla format. It's this one here with the buildings. So that's what it looks like unedited, and it's a ping file. So now if I want to show these with the different edits, I can uncomment them. So I'll crop that. There's just a piece of that file. And I can uncomment more than one. I just need to make some adjustments to make sure that it's resizing the same thing. So if I crop that and resize it, there's the new resized cropped image. And I would encourage you to try these, but also I would encourage you to play around and change some of the values to see what it does. Okay. So there's the transverse. It flips at 90 degrees from top to bottom using one of the corners as an anchor. Okay, and then here's the rotate function with expand true turned on. You can see here it keeps the corners, but changes the size of the image. And then if I want to use a Gaussian blur, I can blur the image. Feels like I'm just not wearing my glasses. And if I want to enhance the color of the image, that's a more advanced filter, and it's actually 2 stages. The first line of code calls the image enhance color, and then I actually tell it to enhance here, and this value is a number from 0 to 100 that will that will actually determine how strong the filter is. So let's look at I got to change this to new image so it's showing the right thing. There we go. Let's run that. And you can see I've colorized it. So what does this all have to do with filters? Uh, most Instagram filters, most of the basic ones that are geared toward changing the color or posterizing an image or doing certain things to produce a certain look and feel to an image, like in the old-timey photographs, um, are just using these sort of things in different combinations. And I will show you some ways that you can use these things in different combinations. Next week, we'll actually get into taking an image apart, because an image also has different color channels, right? It has red, green, and blue, RGB, and transparency. And if you take those layers apart and edit them separately, you can get some really cool effects also. So you can like take the red layer and blur it or sharpen it or rotate it a little bit, and it becomes a really interesting way of looking at image parts. Yes, question? Yes. Yeah, for sure. Yeah. So you can do all kinds of things like that for sure. Yeah. And on Monday, I'll also show you how to add text to pictures, which is kind of a nice thing to do. So fun. So there's more to it. And on Monday, we'll actually get into um, doing a complete program that allows you to choose filters and enter values and things like that, open files, save files, all of that stuff. Today, I'd like you to take this script and just play around with it, download some image files, and run these filters on the images and see what you can come up with.